So now that we've talked about what reactive programming is, and I talked a bit about the Reactive Streams API at a high level, let's talk about some popular implementations of this API that you can actually use in practice. And in fact, you will use these in practice, because that's what we're going to do in the remainder of the course. And we're going to talk about two of them, focusing primarily on Project Reactor. But just for kicks, I'm going to give you some overview of RxJava as well, because you may run across either of these reactive frameworks. RxJava came first, and Project Reactor came later, and there are sort of pros and cons with each. We talked about the Flow API in the previous part of this lesson. However, it's not actually very useful by itself. There's a bunch of things that are sort of useless. So one example would be a fork that has a chain between the prongs and the handle. Not going to be very useful for getting your food. A key that has a flat top. Not very useful. You stick it in the lock and you can't get it out. A wine glass that dribbles the wine down your shirt when you try to drink it. Not very useful. And in the same vein, somewhat humorously, the Flow API by itself is not very useful. And that's because there's too many other things you have to do to use this effectively. Therefore, rather than expecting people to program with the Flow API directly, there are reactive programming frameworks like RxJava and Project Reactor, which add all kinds of additional bells and whistles to that core foundational framework. So the framework is useful in the sense it provides a foundation, but you would never willingly program to it directly. It's too much extra work. So reactive streams implementations enable event transformer operators to be inserted between publishers and subscribers. And so what you basically have here is you have a pipeline or an assembly line of operators that take events that come in, do something to them, and then propagate them down the pipeline. Very similar to something like a Unix shell pipeline. Very similar, not surprisingly, to the concept of Java streams, where you've got these operations, you've got intermediate operations, you have terminal operations, and data, again, flows through the stream. And we'll talk later about how to compare and contrast Java streams with reactive streams. There are some important differences, but some things are similar. This concept of inserting transformer or filtering operators or operations between the publishers and the subscribers. So that's basically the model here. A good analogy for this, of course, would be the water filtration systems that people often have in their houses to get rid of impurities in their drinking water, where you have a bunch of different filters that will remove toxins and other chemicals and so on from the water through a series of phases. And it's also very similar to the aggregate operations in a Java stream. I'll just say very briefly, the main difference between a Java stream and a reactive stream is Java streams are essentially sort of pull-based. The terminal operation at the end of the stream is what pulls the data from the source, or sources, through each of the intermediate operations to the terminal operation where it's joined. So it's kind of a pull model. In contrast, the reactive streams framework is more of a push model, where once a subscriber or subscribers have connected themselves to the publisher, then the publisher pushes the events out. And one of the consequences of this is you have to deal in reactive streams with flow control, because faster publishers can generate data more rapidly than slower subscribers can consume that data. You'd never have that problem with Java streams, because the terminal operations are pulling the data, so it's just pulling it at the rate it can consume it. Whereas with the reactive model, the publishers and subscribers can actually run independently. So you have to be more concerned with flow control. Good quiz question, by the way. So let's talk about some of the different classes that are defined in popular Java reactive streams implementations. And why this is relevant is because programmers of RxJava and Project Reactor very, very rarely use publisher, subscriber, and subscription interfaces directly. You can, but you rarely do. And instead, you use various classes that implement those interfaces. And here's a nice little list of, or a little chart that shows the different classes in the different frameworks and what they do. And there's a nice article here by Thomas Nukowitz, where he talks about RxJava versus Project Reactor and comparison and contrast them. To cut to the chase, because this is 5 years old at this point, his evaluation at the time, which is probably even more true now, is that RxJava had been around longer, so it had more of an installed base, but Project Reactor was newer and was going to be better over time, and I think, in fact, it probably has become better over time. We're using Project Reactor. So in RxJava, which we're not going to spend a whole lot of time on, there are 5 key classes, actually 6 if you look at something called a parallel flowable. There's a completable, a maybe, a single, an observable, and a flowable. Those are the 5 main abstractions in RxJava. In Project Reactor, there's a much smaller number of key classes. There's a mono and a flux and also a parallel flux. And you'll get a chance to play around with parallel fluxes in this class, because parallel fluxes, as we've seen earlier just a little tiny bit in one of our case studies, are very similar in spirit to Java parallel streams. And so you can do parallelism without a whole lot of ceremony. It's more ceremony than parallel streams, but it's bearable. So those are the 2 main implementations that people use. And a mono in Project Reactor is similar to an asynchronous optional, if you remember the optional class from Java 8, where you can have it either succeed or fail, and it may or may not emit a single value. That's where the word mono comes from. And here's a very simple example that we may look at if we have time, that takes a fraction, converts the reduced fraction to a mixed string, and prints it using a mono. The other key class in Project Reactor, which you will get a lot of experience playing with for a bunch of reasons we'll talk about, is something called a flux, which is typical wonderful geek humor. So you have a flux reactor, right, which is something physicists would understand. And it emits an indefinite number, in other words, 0 to infinity, of events, which may or may not succeed or may or may not fail. And the flux also supports something called back pressure, which is a means by which the publisher, the source, can be slowed down so the consumers can keep up, the subscribers can keep up. We're going to take a look at a lot of things with flux. We're going to use parallel fluxes for some things. We're going to use regular fluxes for some things. And perhaps most importantly, we're going to use fluxes with web flux in order to pass between clients and servers, or between a front-end microservice and back-end microservices, objects that can asynchronously stream the emission of their contents to the recipient, which is more flexible and more asynchronous in a lot of ways than passing around traditional data objects like lists or sets. And there's a whole slew of examples that we'll talk about here. We'll look at a lot of examples of fluxes. This is one that's going to generate count number of objects that are emitted from a supplier. And we'll talk about this later. RxJava has a bunch of things too. It has a single, which is very much like a mono, which will either complete successfully or emit exactly one item, very much like a mono. And here's an example where we can have a single emission using a single, and it'll print results on a background thread. There's also something called an observable, which is sort of like a flux, except it doesn't support back pressure. And there's some examples we'll look at here. This is going to take values from 1 to max fractions and then essentially make a random big fraction and emit it to somebody up the stream who's going to process it. There's also flowables, which are very much like fluxes. Flowables can support flow control. There's also a variant of a flowable called a parallel flowable, which can run in parallel like a parallel stream. And here's a fun example that we will probably look at in the context of Project Reactor, but this is the RxJava version, where we're going to run some things and do a rate calculation to switch between British pounds and US dollars, and we do this in a way that will run in parallel. And we'll talk about that again later. There's also 2 other things. There's a completable, which is similar to a Java completable future that doesn't have a return result, and something called a maybe, which is similar, again, to an asynchronous optional, very much like what a mono is. Again, we're not going to spend much time on RxJava. I just want you to be aware that there's other reactive programming frameworks out there, because you may come across them, especially if you program in certain versions of Android. before they switched to Kotlin. So that's the end of the overview of popular implementations of Java reactive streams.